Thanks for joining. We have total 30 classes. This is session number 1 out of that 30. So day number 1, I can say, day 1 of 30 class. Today we are going to discuss about VLAN, and our technology focus is CCIE EI, and that is the updated one, 1.1. So we are going to work on 1.1 and further updates, whatever we have. So this technology is very much going to match that whatever contents we have in our CCI EI 1.1 and their updates. All right, so let's start with packet forwarding. Packet forwarding is something that we want to do within different PCs connected with the LAN devices or routers, etc., etc. And in this same line, I will go and explain you about the VLANs, use of VLANs, and etc. So let's dig in. Let's move on. Okay, you can see the contents here. This chapter covers the following content: network device communication. This section explains how switches forward traffic from layer 2 perspective and routers in layer 3 perspective. And then we'll go and check the forwarding structure. Right. So let's understand. Network devices, what types of network devices we have. We know that we have networking devices such as routers, switches, these type of networking devices we have, right? And
Yeah.
what other networking devices we have?
Firewall.
Firewall, yeah. Firewall, load balancers, firewall, load balancers, any
Wireless
other,
controller.
and wireless network. Then voice type of network, VoIP and communication manager, and so on, right?
Mm-hmm.
Now, the very basic question here is this, that if two devices, they have to communicate, how they will do the communication. And these devices, we have to go and check the topology, that where they are connected, right? They are connected. So obviously, whenever device will get connected, how it is connected. So suppose if I have one PC or laptop, for example, if I have laptop, suppose this is one of the laptop. In this laptop, we have something called NIC card, right? Where you are connecting the cables. Or if it is a wireless NIC card, then it will connect with some SSID. If it is a wired, then you are connecting some RJ45 cable, and then it will go to some switch or some hub, right? So let me draw that. So suppose I have wired connection, and then this wired connection that will go and get connected with some switch. Where it is connecting with the switch? Some port, right?
Yeah, some physical put on the switch.
Some physical. So like that, we have the endpoint connectivity, means this is the PC which is connected with some switch. At the moment, we'll assume that this is Cisco managed switch, some Catalyst 3850, etc. Any type of switch. Okay. Now, if you see this protocol stack, you know that we have TCP/IP model or a TCP/IP model derived from OSI model. Both are different. A TCP/IP model, you have only 4 layers, and OSI model, you have all these 7 layers like physical, data link, network, transport, session presentation, and application.
You said on TCP IP layer, what
This
we
is
have?
OSI layer. This is OSI
Okay.
layer. Yeah,
And you talk about the other layer first. That's how I was doing the thing.
yeah. So this is OSI layer, but in TCP/IP layer, you have 4 layers. From here, they are assuming that part of application. Then you have transport. Then you have internet, data link, and physical. Like that, you have. This is OSI layer. This is good to understand the technology. So if you check this protocol stack, you will find that below, where you are connecting the cables, connectors and all, they are physical. Then you have hardware layer. What is happening that this NIC card, these NIC cards, we have some sort of physical hard-coded address. So they have some sort of MAC address, which is part of the physical burnt-in address within the NIC card. So where you have the hardware address. So this is your physical connectivity. This is where you have the hardware addresses and all. Then the logical part will come into the picture. Generally, these addresses, if you go and see the theory like, CCNA level theory and all, you will find that the addresses are further divided into two parts. Addresses, we have MAC address, that is termed as a physical address, right? And then we have IP address, that is termed as a logical address, right? Logical address. So we have two types of address: physical address and logical address. This logical address is part of network layer. Okay, you can see here that
Yeah.
the network layer, we have logical addresses routing packets. Then we have the transport layer where we have TCP and UDP protocols. So here you can see that layer 4 where you have the TCP and UDP protocols, right? And then you have the application layer will get a start, means session, presentation and application. Those are very much the application layer in the TCP IP model, right? So point here is this, that when I will go and send one packet, if I have one packet, if I send from PC number 1 to PC number 2, how the communication will happen, these layers, how these layers will play their role. That's the thing. So let's try to understand. So now you can see the diagram, updated diagrams here, where you can see that the hub is connected with PC A, B, C, right? And then you can see the switch, which is connected to PC A, B, C. Now, why we have hub and switch? Because these hub and switch, they have different type of architecture. Hub, they are learning and then they are forwarding the packets to all the ports. They are very much worked as a broadcast model. But switches, they are the intelligent devices, and you can think that switches are like many hub in one switch, right? So switches, since they are intelligent and they have some features that they can go and create VLANs and all those things. They have VLANs they can create. They can, nowadays, if they are L3 switches, you can go and run some routing protocols as well, etc., etc. So the modified version of hub is switch, where you can go and control the broadcast within the domain. So now if you go and check this, it will tell the layer 2 forwarding and collision domains. The data link layer handles the address beneath the IP addresses. How it is, I will explain you this. I already told you that MAC addresses are part of data link layer. So this data link layer where you have the MAC addresses. Here you have MAC physical address. Here you have the IP address, logical address, right? So what it is telling that now you have to go and see the communication pattern. If your communication is happening within the switch, that will be very much L2 communication, right? L2 communication, where source and destination, they will go and send, receive the frames. So that's why this technology within the switch, that CSMSCD will come into the picture. Actually, they are running some sort of algorithm. So if someone is sending, other party will listen, otherwise collision may happen. If this is also sending, this is also sending, obviously the channel is not clear, so here collision will happen. So that's why in switches we have one algorithm which is running behind the scene, that is carrier sense multiple access collision detection. What this algorithm is doing, that by any chance if we have collision in the frames, then one of the device will wait for some time, because if we send the frames, he will detect that there is collision, he will detect that there is congestion in network and I can collide with some other frames, right? So that's why they can wait for some time, and then they are sending receiving the packets. Up to this point, if you have any doubt, please ask.
No, we good. We good.
All right, so now what is the role of this VLAN? That suppose if all these devices by default they are in VLAN 1, so that means if they are exchanging their packages in VLAN 1 and all the systems they are in VLAN 1, there are chances of collisions, right? There are chances of collision. So what we are doing to prevent from the collision, we are creating different type of broadcast domains. So that means that if I have 100 of PCs, see if I have 100 of PCs, 100 PCs suppose if I have, then what I will do, that 30 PC will be part of other collision domain uh, or broadcast domain. You can see broadcast domain is different thing. Let's mark this as a collision domain. So they are part of VLAN, maybe VLAN 10. Then rest 30 part of VLAN 20, and remaining 40 may be part of VLAN 55, etc. Right? So point here is this, that do not put all these PCs, right? Do not put all these PCs in same VLAN, rather than create different VLANs and put those PCs in different VLANs, because different VLANs are virtual LANs are different type of collision domain. So you can restrict the communication within the VLANs. That is one of the use of the VLAN, that we have different type of collision domains. We can segregate these users in different VLAN. Okay, so that's the one thing. And still, let's continue our theory related to the packet forwarding. So here you can see that I want to do packet forwarding, and you can see hub versus the switch in the diagram. Okay, hub versus switch, although the pattern is only switch. So what I told you earlier, that if in case of hub, what will happen, that at the moment hub will receive the packet, it will send to everywhere. But switches can do limited collision domain. That means switches can be part of, so the different PCs can be part of different VLANs. So they will broadcast only in the VLAN, right? So let's understand here that collision domain on a hub versus switch. So unknown unicast floods. I will not go to this all the terms. I will explain you from the diagram, so it will be easier. Now what will happen in a switch? Switch has some mechanism to learn the MAC addresses. At the moment you will go and connect the devices, they will go and learn the MAC addresses, because there are some other algorithms as well, that if this device want to send frame, at that moment switch will go and register the MAC address for this particular device over this particular interface for 5 minutes, because they are detecting that they want to send some frame. And when the PC, when it will send the frame first time, obviously it has its own MAC address, and in that frame it has the destination MAC address as well. But first time maybe the switch don't know what is the destination, so he can do the broadcast. That means he will send the packet to all the, not the packet but the frames, to all the PCs connected to him. And from the PC, because it has the destination MAC, so from the PC, from where it can receive the MAC address, so it can reply. So after that they will not flood the frames. After that their communication is very much like unicast, right? So point here is this: the technology is like this, that suppose if you know the destination, then you will send the packet only to the destination. But in case if you don't know the destination, then what you will do? You will do the broadcast. Broadcast means that packet will go to all the PCs, and whoever PCs knows that, oh, this seems my MAC address, this is my address, so why not I will go and start the unicast in the response of the broadcast, right? Any doubt on this?
No, sir.
All right, so this is very much like layer 2 communication. And now you can see the evolution of this VLANs. I already told you that we are creating the VLANs. Why we are creating that? So we can go and segregate the collision domain within one VLAN. Suppose I have VLAN 10. Within one VLAN, obviously the broadcast or unicast will be limited to that VLAN only. So anyways, we are limiting the collision domain. And once you are creating the VLANs are nothing but the tag. They are nothing but the tag value. You are putting some tag, and that is defined by IEEE 802.1q standard. They have the tag protocol identifier. You can see here the diagram, that in the frame, this is a frame. In the frame itself, and I can see the source and destination IP. So suppose this is a packet structure, because in frame you have just the MAC addresses. So this is a packet, VLAN packet. And in this VLAN packet, you can see that IP address is there, that's okay. But you can see that we have 802.1q format. And in this 802.1q format, we have VLAN ID, we have DEI, DOP eligible indicator, PCP, priority code point, and then you have this TIPIT. But basically we are focusing on this VLAN ID. You have total 12 bits for VLAN. So that means you can create 2 to the power 12 bits. That means how, don't know how much, maybe how much 2 to the power 12. That's like 2 into 2 into 2 into 2 into 2 into 2. So what value it is? Let's try to figure out. 2 to the power 12. How much it will be? Can you
And
give me the
12,
number? Yeah. So VLAN ID is 12. That means you can create this number of VLAN. So if
24
2 to the power 2 to the power 1, that is, let me give you the calculation. 1 second.
is 24.
See, 2 to the power 1 means 2, right? 2 to the power 2 means 2 into 2, 4. 2 to the power 3 will be 8, right? 2 to the
Mm-hmm.
power 4 will be, means we have to multiply 2 into this. So this will be 16. Right? 2 to the power 5, that will be 32. Then 2 to the power 6,
Oh, okay.
64. Then 7. Then 8. How much into 2? 6, 5, I think 256. That
Yeah.
is 2 to the power 8. Likewise 2 to the power 9. That will be 5, 1, 2. Then 10, 1024. Then 11, 2048. And then 12. That will be 4096. So we can go and create up to 4000 VLANs, 4096 VLANs. Few VLANs are reserved. We are not using that, but yeah, generally we can create from VLAN 1 up to at least 4000 with this VLAN. So we can create total 4000 VLANs. Theoretically, practically, how much device will support? Generally, we
And
are creating, yeah,
this is
100
default for every switches.
default for every switches. Yeah.
Okay.
All right. So these many VLANs we can create, no problem. Let's move on. And how we are creating this VLAN, that we will check in our lab as well. Oops. So we are going to the switch. Actually, we are creating the VLAN database. Name of the VLAN, say VLAN 10 name, VLAN 20 name, VLAN 99 guess, like that we can go and create, and then we can verify as well. Then we can go and check show VLAN brief, summary ID and name, etc. Right? These are commands that verify the VLANs. Here you can see. So it's very interesting. It's actually very much interesting to know this fact. Suppose I have one switch, and this switch I am connecting with PC. Suppose PC1 and PC2. Now this particular switch, suppose the switch name is, let me write the name here for the switch. Say switch 110, and this may be PC 11, PC 12, and it's connected over one interface or other interface. Suppose this is Ethernet 0, 0. This is Ethernet 0, 1. And then this switch is connected with two other switches, for example, here and here. And then these switches have the connectivity. So now you can see the diagram. Suppose this is switch 101, and suppose this is switch 102. Here you have the port channel. Here also you have multiple interfaces connected. Also you have a multiple interface connected. At the moment you can think that this is the topology. Now from switch to PC connectivity, right? So this is your terminating devices, right? Here you are terminating the connection, ending the connection. So this we are assigning with some VLAN. Suppose this switch has two VLAN, VLAN 2000 and VLAN 2001. So suppose I will go to this interface and I will assign the VLAN 2000, and this interface I will go and assign the VLAN 2001, right? But since this is switch to switch connection below, switch to switch connection, so I will make this interface as a trunk. Trunk means passing all the VLANs. So whatever VLANs you have over the trunk interface, you can go and pass it. But if you are passing only one VLAN at a time, so that will be access. That will be access. VLAN mode access, VLAN mode access, and these are the VLAN mode trunk, right? So if we have creating port as a mode access, here you can see the access. That means it will pass one VLAN at a time, right? And if we are passing multiple VLANs, then that will become trunk, or over the trunk, we can go and select some sort of VLANs and we can add only those VLAN entries there, right? Any doubt, any problem up to this?
No,
So,
nope.
fine. All right. So why not let's go up to this point and check this in a switch. Let me try to open my switch and I will explain you up to this point. So what are the things we want to do? I want to create a VLAN, then we'll verify the VLAN. Then we'll go to the interfaces and over the interfaces, we'll go and assign the VLANs like that. Okay. So let me try to open one of the switch and I'll pull in this screen. And then I'll show you the configuration.
Yep.
You know if you can see that this font is very small. Let me change these settings. Let me increase the font a little bit so you can see.
What are you using? EVNG or using GNS?
We are going to use EVNG only.
Okay.
Yeah. You can use GNS as well for your practice, but EVNG is better. Okay, you can see my screen now
Yes.
full-fledged. Okay. So what we want to do here, we'll go and create one VLAN. For example, VLAN 2000. You can give any name. If you do not give the name, it will take any name. I'll show that. And 2001. Once we go and create these VLANs, then we can go and check show VLAN ID 2000. So here you can see that VLAN by default it created a name VLAN 2000. It is assigned to some ports. We'll see that. Likewise, I can go and create VLAN 2001. You can see VLAN 2001. It's easy. Apart from that, to show, let me exit from here. Show VLAN brief. You can see the VLANs in brief, right? Now, as per the diagram, what I want to do, I want to go to interface E0/0, right? And over this interface, I want to make switch port mode access that only allow one VLAN at a time. Switch port access VLAN 2000. Likewise, I want to go to the interface 01. Here also I want to do switch port mode access and switch port access VLAN 2001. Right? Now if you want to show the interface, you can see these configurations we have done. Right? This part of configuration we will do later on, but I can go to these interfaces and I can make them trunk or allow something over the trunk. Right? Till this point, it's okay, right? Everything you can understand. So what I will do that let's explore this little bit more. And I have one more switch. Let me go and draw one more switch here. So suppose I have one more switch. Let me try to draw here. And this switch again connected with two more switches. So I have one branch. So For example, branch number 3, and assume that this is one of the headquarters. This is headquarter diagram, and this is branch number 3, BR3. In this branch also I have such type of connectivity. All switches are connected to each other and some bundling are there. Later on we'll explore on that. The switch name here in this branch is, this is switch number 601, this is switch number 602, and this is switch number 610. Now this switch, again they are connected with PC61, PC62. Suppose this is host 61, this is host 62. Now this is interface 00, suppose E00, and this is interface E0/1. Right, so here also I have to go and pass the VLAN, same thing that I have done here. But on the uplink, which is Ethernet 2/0, for example, and Ethernet 2/1, I have to make sure that they are trunk, but over the trunk mode, they are passing the VLAN 2000 and 2001 both. Now let me know if you are able to understand the scenario. Are able to understand the scenario, the scene here, what we want to do?
Yeah, you added the 2 switches and you want those 2 switches to power VLAN. To
Yeah.
forward the VLAN database or VLAN traffic to the switch in the switch that connected the 2 hosts.
Yes. Right. You're able to understand that?
Yeah.
Great. So let me pull this switch here, and what we will do, that again we will go and create the VLAN 2000 and 2001. Once we do the creation, after that, in this case, we are going to configure both. Both means, let me clean this. Actually, I want to clean the earlier diagram. If I can clean. Oh, it will not clean this. First, it will clean this. Anyways, you can understand this diagram here, right? So let me clean the entire picture. Now, I have another switch. And this switch, how it is connected. This switch. Let me redraw the diagram. Or I can do one thing. No problem, no worries. I'll redraw the diagram just to make sure that parallelly you can visualize the topology as well. So this time there are 2 switches on top and one is below, and their connections are like this. And they are part of some port channel. Maybe we'll see later on if they have some port channel, or maybe they don't actually. They have single line connection. They don't have port channel like the first example. They have single connectivity. But here also you have 2 PCs connected. So suppose PC1 and PC2. Let me quickly write the name. So this is your switch 601, and this is your switch number 602, for example, the naming of the switch. This is your switch 6110. Oops, 6110, 610. And this is your host, say host 61. and then you have host 62. This interface is E0/0, and then you have interface E0/1, but the uplink that you have, that is 2/0 and 2/1. Your task is this, that the uplink you have to make this as a trunk, but you need to pass only VLAN 2000 and 2001 over the trunk, and this is part of access port. Right, now you can see that same sort of configuration you have done here in the other switch, so you can check the history. And
Uh, 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 Ranesh.
mhm,
So I got a question, Ray.
sure.
So the switch system, that switch we just talked about, switch system.
Mhm.
Um, I
Switch
thought on
system,
that
where is switch system? Switch
read
number
that switch number
16.
six.
Yeah, 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 yeah.
Yes, system. I
16.
thought on a switch we're supposed to create multiple VLANs so that the host PC can sit in different VLANs. Because right now, as it stays right now, the two host PC will be in the same VLAN, right?
VLAN 2000, VLAN 2001. Both are in different VLAN that we
So
have
you're
to
gonna
create.
so you're
Yes,
gonna create the VLANs on switch
yes,
sys 10. Okay.
yeah. So we'll create VLAN 2000 and VLAN 2001. You can see my
Oh
configuration.
yeah, we did that already. Yeah, we did that.
Yeah. So we have done this in switch number 110, like that I have created in 610.
Yeah, yeah, yeah,
Right.
yeah.
This is HQ switch and this is branch 3 switch.
Mm-hmm.
Okay. Now you can see VLAN 2000, 2001, and then we are going to the interfaces and assigning the VLAN, going to interfaces and assigning the VLAN, right? So what
Mm-hmm.
I will do, simply I'll go and copy this config, because same thing I want to do here as well.
Mm-hmm.
I'll go here and paste. So these portions completed, like access,
Mm-hmm.
but still we have to go to interface E, for example, 0/1, and here I have to add one command, switch port,
Mm-hmm.
trunk, allow, VLAN, add 2000, 2001.
Mm-hmm.
Got this command? So if it is simple switch port mode trunk, then it will allow all the VLANs. But what
Mm-hmm.
we want to allow these VLANs. And for example, if I want to allow the default VLAN as well, so I can give one extra line here, 1
Mm-hmm.
comma 2000 comma 2001. Now if you go and see interface E2/0, let me show you all those 00, 01. These things we have configured. You see?
Mm-hmm.
Now, if in the interface, if you do not have mode trunk and encapsulation dot one q, then they will not take this command. They will simply reject this command. They will tell, oh, first convert this to trunk and then only run this command. So for other interface, what I am telling, if I have 2/1, I have to make the switch port mode trunk. Switch port trunk encapsulation dot one q, and then only I can go and run switch port trunk, allow VLAN, add 1, 2000 and 2001, and then we can go and check the interface configuration like this, right?
Mm-hmm.
Okay, so this way we are creating the trunk access, and those things are explained here, right? Then you can make the trunk, like see trunk. Then you can go and check the interface trunk. We can go and verify those things, like show interface trunk. So it will tell you that which interfaces. In our case, we have created the trunk. In this switch, we haven't created the trunk. We have created the trunk here. So I can go and check to show interfaces trunk. So it will tell you 201 mode is on, 8021 is on, native VLAN is 1. Mode is on, this is trunk. What VLANs you are allowed? 1, and then 2000, 2001. VLAN 1 and 2000, 2001. Right? So like that you can verify this. Correct? The native VLANs, what is native VLAN? Generally by default VLAN 1 is the native VLAN. Native VLAN is a VLAN which do not have any VLAN tagging. So we have created VLAN 2000, 2001, etc. So they have some tag value like VLAN 2000 or 2001, they are the tag value. But if you have any VLAN without tag, that is nothing but the native VLAN. They are native to the switch. So in 8021Q standard, any traffic that is advertised or received on a trunk port without the tagging, it is the native VLAN. So in our case, VLAN 1 is the native VLAN, which has without a tag. So you can see VLAN 1 will be the native VLAN. It don't have the tag. Then what we have done, we have created the allow VLAN add. We have added the VLANs. So you can see that allowed VLAN. If you want, you can add one extra VLAN. So suppose if I have a switch, and suppose I'll go and create one more VLAN. For example, VLAN 2002. And only this VLAN I want to add to the interface. Interface E2/0. So switch port trunk allow VLAN add 2002. You can add this. You can see that only this VLAN will get added. Now, if you have to remove one VLAN, switch port trunk allow VLAN remove 2002. So then you can remove as well one VLAN. See, 2002 got removed. Okay, you are able to understand all these things, right?
Mm-hmm.
Easy,
Mm-hmm.
straightforward.
Very straightforward.
All right, so let's move on and understand more. So now we are able to understand the VLAN part. Then in this section, we have little bit explanation about the MAC addresses. MAC addresses, what are the nature, static MAC address, dynamic VLAN ID match MAC addresses. We know we can go to the switch and we can check show MAC address table, dynamic. So generally these switches, they are learning these MAC addresses automatically and they are containing it for 5 minutes or I think 300 seconds, right? So you can go to the switch. So we have one switch. I can go to the switch and I can go and check. So MAC address table. At the moment, we are not doing any communication. So it is not learning any MAC address over the interfaces, but that is the default nature of a switch. Switch can go and learn the MAC addresses. Then there is one very interesting command. Show interface name switch port. It will tell you everything about that switch port. This is a robust command and it will give you robust output actually. It's a command that will give you so much information about the interface. And see, everything it will tell you. Mode, access, static encapsulation, and then private VLAN informations and all those database and everything. It's actually very interesting command which will tell you almost everything about the switch port and their status. Then we have the interface status. We can go and check the interface status of the switches. You can see here the list that which interface connected. So what are the things it is telling? The port name, the naming, the status, the VLAN associated, duplex, speed. Very nice output we have, right? So far we have discussed about layer 2 like VLANs, layer 2 forwarding, but in between, if you have a router, so now you can see the things are changing, that now I have a router in between. And if you have router in between, then how the traffic pattern will change, because once you have router connected, routers, they are working as a gateway devices, right? Routers, they are working as a gateway devices. So once you go and connect the router, then they will go and build some sort of gateway information. And then now your one gateway will go and exchange to the other gateway. So you can see that 1.0 will get converted to 2.0, means your source may be in 1.0 network. You can see 1.1, but your destination is 2.2 network. That means you need gateway exchange information. Otherwise, you will not reach to the destination, right? So then how the packet forwarding will happen? The source device must add a appropriate layer to header, source and destination MAC addresses, but destination MAC address is needed per hop. You need per hop MAC address. This interface MAC address, this interface MAC address. You can see both are different, A1 and B1. The device looks for the next hop address entry in the ARP table and uses the MAC address for the next hop IP addresses entries in the destination MAC. Some lines are overwritten here, but I will correct this PPT. The next step is send the data packet. Means point here is this, that somehow you know, you should know what will be your next hop information. Next hop information will be containing via the MAC addresses. So you should know the MAC address of your next hop. And if you are unable to reach the destination, so here some sort of actually ANDing process is happening, and then the frame, the sender, they'll come to know that this destination is not within the switch, like within the same network. So then it will request that router that I need the gateway information for this particular IP, and then router will tell the gateway destination is 2.0, and then finally you can reach here via the next hop MAC addresses only. Like this, the packet forwarding is happening if you have routers in a network, connected in a network. Right, so easy, straightforward, no much thing here is this. If routers are there, you can reach to the destination via the routing entry, right? So finally, the router then modifies the source MAC addresses, and MAC addresses are changing per hop. So that is important information. Per hop, MAC address will get changed because MAC addresses are there local to the network. IP addresses are there global to the network. IP address has global reach. MAC addresses has a local reach. Per hop, per next hop, MAC addresses has to change. But the destination IP address will never change. See, the source IP and destination IP, source IP may change, that's okay, but destination IP will never change because this is fixed, because you have to reach to this destination. But this MAC addresses will get changed every hop. Here it will get changed, here it will get changed, here it will get changed, right? So that's the local communication versus the global communication thing. Now IP address assignments and all these things we can discuss later on, but yeah, you can go to the interfaces. I can assign IP address, IPv6 addresses. If you have some router on a stick scenario, means router is working as a gateway, then you can go and create multiple VLANs over the routers, create the gateway IPs and all. Okay, these are
Since it's
just
a router, since
Mhm.
it's a router, go back one more time, please. Go back. Yeah, right there. It's a router. Why were you using encapsulation .1Q? Oh, okay, router on a stick.
A
Okay, I
router
got
and
it.
stick, yeah, yeah.
Okay, got it, got
So
it,
you
got
have
it. That means
multiple,
using
yeah,
yeah, you're using
routers.
multiple VLANs and you wanted to go through the okay, got it.
And some of the basic commands we have. Anyways, these things I will show you later
Sub
on
interface.
in the
Okay.
IP sections. And then finally you can see that there is some process switching that the switches are doing. So this safe and all those things that I will cover next class. So few slides are there that I will cover in next session. What is safe and
What
all,
time
what
you
is.
want us to be starting?
Let me pause the recording. So we are done for the session day 1 today. Let me pause the recording.